Here we have to give the details of disinfectants. You know what is a disinfectant? For a simple example, phenol, which is used at home, hotels, hospitals for killing microorganisms at different places like bathroom or laboratories, or even to clean some vessels. So such things, such chemicals are called disinfectants. So they are to kill the microorganisms wherever they are applied. According to Drugs and Cosmetics Rules 1945, Schedule O, the disinfectants are classified into two types: black fluids and white fluids. These are generally the derivatives of coal tar acid or similar acids. Anyway, this black fluid said to be very stronger and it needs emulsifier to get dissolved in water. So emulsifier like caustic soda is added to this black fluid to make it dissolved in water. Then only it can be easily used for the disinfective purpose. White fluid, this is also the derivative of coal tar acid and somewhat lighter, doesn't need emulsifier to get dissolved in water. Now these disinfectants can be graded in the sense to what extent they are effective by the value called RW coefficient value. RW stands after the name of the scientist who found this method to indicate the effectiveness, strength of the disinfectant. Riddle Walker, the name of the scientist after whom it is named. That is the strength of the disinfectant, grade of the disinfectant, according to the Schedule O of Drugs and Cosmetic Rules 1945. Now here, grade 1 disinfectant is said to be having RW coefficient of 18. Disinfectant grade 2 should have a minimum of RW coefficient value 10. Disinfectant grade 3 should have a minimum value of 5 RW coefficient. Now how this RW coefficient value is found? Here a disinfectant's strength is compared to the strength of phenol in dilution of 1:100. You assume that the phenol in dilution of 1:100 kills a type of microorganism in about 5 minutes, in a duration of 5 minutes. And the disinfectant to be compared is diluted in different proportion to see in which dilution that disinfectant can kill the same type of microorganism in 5 minutes. Now here for example, the disinfectant taken for the test that kill the microorganism, selected microorganism in 5 minutes in a dilution of 1:1200. But at the same duration, the phenol in the dilution of 1:100 is killing the microorganism in 5 minutes. Now here to calculate RW coefficient of that disinfectant, for which we want to find out RW coefficient. The dilution factor is divided. Dilution factor of the new disinfectant is divided by dilution factor of the phenol. Now here in this case, the dilution factor of phenol is 100. Dilution factor of disinfectant is 1200. So 1200 divided by 100 equal to 12 is said to be the RW coefficient value of the new disinfectant. Here you say A disinfectant, for which we find out the RW coefficient value. So accordingly the strength or the grade of a disinfectant of any type. So here the comparable disinfectant is phenol in dilution of 1:100. So in what duration it kills a particular type of microorganism, and comparatively at what dilution there the new disinfectant can kill the same type of microorganism in 5 minutes. Accordingly here this RW coefficient value for a particular disinfectant is found. Now there are different types of chemical disinfectants used in different places, like hospitals, industries, whatever the place where there the microorganisms to be killed, controlled. So here are given some the chemical disinfectants: phenol and phenol compounds, halogens, iodine, chlorine, quaternary ammonium compounds, formaldehyde, ethylene oxide. Details of if any alcohols, heavy metals, dyes, detergents may also be included. So these are all the major disinfectants used at different places in order to kill, control microorganisms. Now here we can say phenol and phenolic compounds. Phenol, carbolic acid, was first used as disinfectant by Joseph Lister in 1865, and such things of phenol and phenolic compounds are used to disinfect the lavatories, contaminated utensils, instruments, and such things at different places. Now the phenolic compounds are phenol, cresol, phenylphenol, hexyl, resorcinol, hexachlorophene, also used as disinfectants. Effect of phenol and phenolic compounds. So now the phenolic compounds, aqueous solution at 5%, phenolic compounds able to kill the fungal cells of microorganisms effectively, vegetative cells in the sense the growing. The microorganisms usually will divide, multiply into many in a short duration, and such cells are called vegetative cells. So these phenol and phenolic compounds can kill these microorganisms which are vegetative in nature. And also they are bactericidal. Bactericidal means to kill the bacteria. And bacteriostatic. Bacteriostatic means the multiplication of bacteria will be arrested. And fungicidal, the fungi will be killed. And that way. So RW coefficient value of phenol is said to be somewhat higher compared to the other disinfectants in general used. Mode of action of phenol and the phenolic compounds, that is how they act on the microorganism and kill them. And one of such controlling methods is disruption of cell, the complete damage of the cells, precipitation of cell protein, automatically the cell will die, inactivation of the enzymes for their activity, physiological activity, and leakage of amino. When the body wall of the microorganism is damaged, automatically the amino acids, protein components will be leaking out. That way that will cause death of the organisms. And halogens, in particular iodine and chlorine, are said to be a good disinfectant, used both to clean the surrounding as well as used on the human being as an anti-infectant. So here you can see the details of chlorine and iodine. Kills all kinds of bacteria, and also it is highly fungicidal and reduces microflora of skin. And also the chlorine and iodine preparations used for disinfection of water, air in the form of iodine vapor, utensils. So they are also killing the microorganisms as oxidizing agent. And here the chlorine and the chlorine compounds, hydrochlorides, calcium hypochlorite, also known as chlorinated, and sodium hypochlorite are used widely as water disinfectant. Chlorine compounds, here we have given the list of chlorine compounds which are used as disinfectant, and they are also used to bleach the household areas, utensils, sanitizing agents and disinfectants. Mode of action of chlorine is due to the hypochlorous which is formed when free chlorine is added to water. The oxygen released in this reaction is a strong oxidizing agent, modifying the structure and its action on cellular constituents such as proteins, and also direct combination of chlorine with the proteins of the cell membrane of the microorganisms that way. And quaternary ammonium compounds, here whichever the ammonium compound with 4 angles covered by CH2 are generally called quaternary ammonium compounds. One of the examples is Zephyron and cyprin chloride, that way we have given the list. And they are also useful for controlling the microbes on floors, walls in hospitals, dairy farms, poultry and fishing industries, restaurants and other public places, that way. Here the mode of action is denaturation of protein, interference with the glycolysis, enzymatic activity and cell membrane damage. Thus alter the permeability characters of cell structure. That way the microorganisms will be killed. So most of the disinfectants acting on the cell membrane and its permeability, protein components, which are all very essential for the life of the microbes. That way they are damaged and killed. Then formaldehyde, and a very familiar in disinfectant, and the effect of formaldehyde both in form of aqueous form, solid form as well as gaseous form. And here also the mode is they kill the fungal spores, bacteria, viruses, and also to used for sterilizing urological instruments, lensed instruments, respiratory therapy equipment and all. In what way that can kill the microbe is to disturb the protein and the nucleic acids and cellular substances of the microbes. That way that can kill the microbes. And the sterilization of plastic devices. Now here if you want to know the difference between disinfectant and disinfection and sterilization. Disinfection is to kill microbes which may be at certain stage, particularly in vegetative stage. Sterilization is the material used for sterilization may kill all types of microbial form which can make the instrument very infective, like plastic syringes, blood transfusion apparatus, plastic pipettes. Even these are all sterilized to be fully cleaned out of the microbes. And here also some gaseous sterilizations are ethylene oxide, beta propiolactin and formaldehyde, that way. And these sterilizations are the materials used for sterilization or disinfection. In common you can assume damage to cell wall of microbe and changing permeability of the cell wall membranes, cytoplasmic membranes, and then enzymatic components in the microbes, inhibition of enzyme action, protein energy synthesis, and changing or damaging the nucleic acids. That way, in general, more or less most of the disinfectants that can damage the microbes in such method of disturbing the activity of the enzymes and so on. So bactericidal, bacteriostatic action as well as disinfection and sterilization action. So that way you may have an idea about those substances which are used for disinfection and sterilization